Welcome to this explainer. Okay, today we're embarking on a pretty fascinating journey. We are going to trace the path from the oil and grease, totally hands-on cockpit of a small airplane, straight to the absolute bleeding edge of theoretical physics. It's an incredible story, so let's just dive right in. I want you to think back for a quick second. What exactly were you doing when you were 14 years old? You know, maybe navigating early high school, playing video games, or just kind of trying to figure out your place in the world. Well, 14 is the exact age our subject today, Sabrina Gonzalez Pasterski, built a single-engine airplane. And yeah, you heard that right, she built it. We're not talking about a little remote-controlled model here. This was a fully functioning, real aircraft. It is just a staggering achievement, and it perfectly sets the stage for a mind that honestly just doesn't accept conventional limits. You can really see her undeniable early passion for aerospace engineering when you listen to her own words. As she describes it, taking to the skies provides this kind of freedom that you literally can't compare to anything else. And this definitely wasn't just some fleeting weekend hobby. Sabrina poured over 2,200 hours into studying aircraft plans and maintenance manuals. I mean, long before most people even get their driver's license, she was already flying a Cessna 150. She built this intense, deeply hands-on relationship with the literal mechanics of flight. Now, just think about the contrast between where she started and where she eventually ended up. We're talking about mastering engine instruments, fuel levels, oil pressure, oil temperature. These are incredibly grounded, highly tactile systems, right? You can touch them, you can measure them, you can actually go in and fix them with a wrench. Understanding all this requires a deeply practical mechanical mindset. And yet, this very same nuts and bolts foundation somehow served as the launching pad for her incredible trajectory into one of the most abstract, mind-bending fields of science you can possibly imagine. From the cockpit to quantum fields. If you were to walk into Sabrina's workspace today, you'd actually see this fascinating bridge between these two completely different worlds. You'd spot old undergraduate textbooks sitting right alongside those aircraft manuals. And all of it is grounded by this beautiful Van Gogh-style painting that her mom actually made for Perimeter's Day of Discovery. Which brings us to exactly where Sabrina is today. Allow me to formally introduce her. Sabrina Gonzalez Pasterski is a brilliant theoretical physicist at the world-renowned Perimeter Institute. Specifically, she works within their quantum fields and strings group. But her primary role, the work that's literally turning heads across the entire scientific community right now, is her position as the lead of the Celestial Holography Initiative. And look, I know, that sounds incredibly intimidating. Okay, so let's dive into this. Celestial holography. It sounds like something pulled straight out of a sci-fi movie, doesn't it? But it's very real, and it is very serious physics. To truly grasp the sheer magnitude of what Sabrina and her team are pulling off, we need to take this complex, jargon-heavy terminology and just break it down into two highly accessible pieces. So let's look at the first word: celestial. When Sabrina's team uses this word, they literally mean looking up at the night sky. But they're asking a massive, mind-boggling question. How do you encode the entire physical universe as a hologram? In this context, they're dealing with what they call almost flat spacetimes, by mathematically getting rid of the cosmological constant. By doing this, she's attempting something truly monumental. She's trying to apply the holographic principle not just to some abstract mathematical whiteboard, but to the actual real world we live in. And then we have the second half of the puzzle, holography. The crucial point here is understanding what holography actually means in a physics context. It's the mathematical notion that quantum gravity can actually be described as a lower dimensional theory that completely leaves out gravity. Think of it like a 3D image being projected from a flat 2D surface. So when you smash these two concepts together, the celestial map of our flat spacetime and this holographic mathematical framework, you get one massive universe redefining concept. They are literally trying to decode the fundamental language of the cosmos. Now, you'd probably expect someone with a job description that involves redefining the universe to have a pretty healthy ego, right? But what is so striking about Sabrina is her profound humility. Despite leading this massive initiative, she actually often refers to herself as just a grad student. She doesn't view her work as some isolated act of genius, but rather as part of a really long, humbling legacy. To her, the whole physics enterprise is about trying to understand the fundamental laws of nature, and she freely acknowledges that most of her days are just spent quietly in the department, reading, learning, and standing on the shoulders of the giants who came before her. But we kind of have to contrast that humility with her actual reality. She might call herself just a grad student, but the rest of the world sees her very differently. Her incredible contributions, especially in education and inspiring the next generation of scientists, absolutely have not gone unnoticed. In fact, she was honored with a highly distinguished award for those contributions. And just to give you a sense of the caliber of this recognition, she received her trophy sharing the exact same stage as legendary Olympic gymnast Simone Biles. I mean, game recognizes game, right? Excellence recognizes excellence. This naturally leads us to a fascinating question, and it's one I want you to really think about for a second. How do scientists actually reach that ultimate goal? Everybody in the field wants to make that amazing discovery. Everyone wants to win the big prizes, uncover the hidden truths of nature, and go down in history as an awesome physicist. But what does the actual day-to-day path to get there look like? Because every scientist eventually faces a crossroads. For a long time, the old, cutthroat way of doing science was basically to fight the competition. Hide your notes, seek individual glory, and try to be that lone genius who crosses the finish line first. But Sabrina champions a completely different approach, and it's one deeply fostered by the culture at the Perimeter Institute. They realize that if you just step away from that hyper-competitive game, there is a massive advantage to be found in collaboration. By talking more, sharing freely, and daring to dream bigger together, you actually improve each other's ideas so much faster. And this reveals a core truth about what it really means to be a great physicist today. At places like Perimeter, it isn't just about locking yourself in a dark room, doing your isolated research, and publishing a paper. It's about genuinely caring about the entire physics enterprise, the whole shebang. It's about fostering a community where ideas can collide, merge, and evolve. It's ensuring that the pursuit of understanding nature remains a shared, collective human endeavor. Which perfectly brings us to this incredibly empowering concluding thought from Sabrina herself. Knowledge is power. Her journey, from turning wrenches on a Cessna as a teenager to unraveling the holographic nature of the cosmos, proves that when sheer curiosity is paired with collaborative knowledge, there are literally no limits to what we can understand. So I'm going to leave you with this final thought. If the universe truly is a giant hologram, and collaboration is the ultimate key to decoding it, what piece of the puzzle are you going to share with the world today? Thanks so much for joining me on this explainer, and keep looking up.